I've had to do a bit of a stack unwind this week because I was originally thinking of showing you another video with a little bit more about the yield return phrase, and as I was putting together the example for that I started using tuples, so then I thought, well, maybe tuples would be a good place to start actually, and then I thought before I can tell you about tuples we've got to know about anonymous types. So I'm going to start this week showing you anonymous types, then next will be tuples, and then finally, if I can remember why I came back into the room in the first place, it will be this other look at yield return. But what we're going to look at now is quite an old idea in C#, the idea of anonymous types. And this came in C# version 3 along with LINQ. And it's really something that works alongside LINQ that is absolutely necessary. So let's take a look at some examples. And what I've got here is a database, and it contains essentially just one table, this thing called book. And if we take a look at the actual data, we can see we've got a table there and our book has these various columns. And the reason that we have anonymous types in C# is essentially to be able to emulate a particular feature of SQL. So if I just kick off a query here, and then I could say select star from books, and then when I run that, we see we get the results, and the point is that star simply means give us all of the columns. But what we can also do in SQL is be selective about it. So I can say select title, comma, author, and when I run that, we just get those columns that I've asked for. And that can be very useful if you are, as a user, actually directly issuing SQL so that you're looking at results and trying to process the data for yourself. But when it comes to writing software, things are a little bit different. So if we now go and look at what's happening with the software, what I've actually got here is a website. And if we look at the controller, for the book controller, then we can see that when we have something like the collection of books, that is our entity type. However, what I've also done is created a model. So here we've got a book model, and our model is actually a subset of the total of the properties on our entity. And this is a particular bugbear of mine because you'll often see in all sorts of documentation the term model used both to mean the class that we have for taking data from the database into the program, and also what we have from taking data from the controller into the view. And although they're similar, they do fulfill different purposes. And it tends to be that the one that we have for taking the data from the controller to the view, which is the model in MVC, is often a subset of what I would call the entity from Entity Framework, which is what we get from bringing the data in. And so we can see that here, the book model only contains the fields we're interested in, whereas the book has all of the fields. And in a sense, that's a bit like what we were doing with that SQL earlier, when I could just select the columns that I wanted. And so in our controller, although when we're looking at all of the books or when we're looking at a single book, we get back the entity, we then cut it down to give us what we want in the model. And so if I run that up, and if we go to details, then we can see that we've just got the subset of the entire data. And that's all very well, but the slight problem with that is in order to get that subset, I had to predefine it. So I had to write this class book model that only has ID, title, author, and publisher. And if I wanted a different subset without anonymous types, then I would have to write a different book model. So if I wanted one that, say, had the blurb and the title and nothing else, then I would find myself, if I was following this pattern, writing a different book model. And that's where we can have these anonymous types, because what I could do would be something like here. I could just say var model equals, and then the syntax of the anonymous type, we say new, and then we don't give it any type at all, and then we can just say id equals entity dot id, title equals entity dot title, and blurb equals entity dot blurb. And then we can see if we just hover over that it's an anonymous type with 3 fields, an int and 2 strings, ID, title and blurb. You can also actually see by graying those out, it's telling us that I've actually written more code than is necessary. So actually, because the property I'm initializing it to is called ID, it will assume that that's the name of the generated property I want in my anonymous type. And the same goes for all of these. So in many situations, if the names that you want in your anonymous type correspond exactly to the property names in what you're initializing it from, you don't need to put them in there at all. And we can again see if we hover over model that we've got exactly the same thing. However, there is a slight downside to that, which is although we can declare using the var keyword a model of this type, there is absolutely no way we can specifically code that specification. So where we've got that var there, I cannot declare a function with that return type. I cannot declare a function with that parameter. And when it comes to passing this to the view, we then can't in the view specify what the model type is going to be, because here we're specifying a specific type, whereas if this were an anonymous type, there's no real way of doing it. You can just about manage with weakly typed views, but you lose so many beneficial features, and I've never seen it done in practice. So although it is possible to get a subset of the entity using an anonymous type, it's not really that much benefit when we're doing something like MVC. And in fact, if we think about it in OO terms, it also isn't really very object-oriented. And as I mentioned back at the beginning, this is a feature designed to mimic the way SQL behaves with relational databases, which are not really in any way object-oriented. And the problem I would specify here is that if we need to take a subset of the properties of the class, we've got to ask ourselves, well, isn't this class breaching the single responsibility principle? If it is not addressing one single feature, if we can cut it down into something smaller, then it's a breach of the SRP. And I think if we look at this entity, I have deliberately designed it so that it does breach the SRP. Look at all this baggage it's carrying around. Okay, ID and title, that's reasonable. Blurb, possibly. Publisher, well, publisher would be an entity in its own right. That should be a separate class, a separate table. That would be where we get the publisher address from, similar with author. So we can see that this class is breaching the single responsibility principle, and that is really telling us why we need to cut it down when we start accessing it. There is, however, it's worth saying, some possible performance benefit from this. If we just look at, say, the index, so in this case we're getting all of the books, but we're only getting the title and the author and the publisher. If we run that up and take a look in the console, so there we've got our list, and you can see here in the actual SQL that's emitted, it's only fetching ID, title, author and publisher. So it's not fetching the entire entity and then just cutting it down in the program's memory. It is simplifying the call. And so if there were a huge amount of data, it might just about be arguable that taking a subset would have a performance benefit. One situation, however, where I find this sort of thing can be useful is not when we're dealing with MVC, but when we're dealing with Web API. So here I've got an API controller that is accessing that same database entity. And so we can see that we've got a get method that does really exactly the same as we had with the method on the books controller, just gets all the books, but reducing down the columns for this book model. And so if I run this up again and then bring up the advanced REST client, and then if I just call the get there, then we can see we've got the results back as some JSON. But if I were to want to change that, then I can actually do this kind of ad hoc thing. So on this action result, I could actually specify not that it's an IEnumerable of book model, but simply that it's an IEnumerable of object. And then here I could do this in the anonymous way. So I could just change that to new, and let's do what we had before. So let's go for blurb equals b.blurb. And because the JSON processing of this object is going to be done dynamically on the fly anyway, we don't need, in that case, to have a predefined class. So now when we run that up and run the query, now we can see we've got blurb in there, and we did that without having to specify a named class. So that is a genuine use of anonymous types where we don't ever really hit the point of being in trouble because we don't know what they are. So I will use anonymous types, not very often, but reasonably often with Web API, because I can simply return an object and get the JSON serializer to do the work. But when it comes to MVC, I find this sort of thing is just not worth it. You might as well put together the appropriate class to deal with the model. There are a couple of places where anonymous classes are actually used very specifically in MVC. One of them is to do with routing. So if we just scroll down to the edit, so after we've done a save changes, we need to redirect back to the details action, but the details action takes parameters. So you can see there, we pass in the parameters as an anonymous object so that ID is what will be passed into details up here. And similarly, we can see that actually on the details where we have the edit. Again, in the view, we need to pass the parameters as an anonymous type. The other place actually we can see that is in the edit view itself. And you can see here that actually I've got a mixture of what we have in .NET Core, which is using tag helpers, which are really a far better way to do this. But just to show you this, I've left one of these as the more old-fashioned, but still valid in MVC Core, that we've got the HTML helpers. And one of the issues with the HTML helpers is when you've got something like that text box 4, how do we pass things like class information through to the generated HTML? Much easier to do when we've got the tag helpers, but the trick we do is something like this. We would, as a second parameter, pass in an anonymous type, and then we would, and the IntelliSense is really nasty here because I'm trying to write an anonymous type and it's giving me what it thinks the type is. But we have the anonymous type, and then we could say something like class equals, and then what we've got there, form control. You'll see one slight additional problem here. Class specifically is a keyword in C#. And so you may have seen this. When we do this, we actually have to precede that by the @ symbol. That's not going to happen for every one of those attributes, but it's because class is a keyword. And actually that @ don't be fooled, it is not the razor @. Remember, the razor @ takes us into C#, so we're already in C# here. What we've got there is what is known as the verbatim symbol, which has been around in C# since the very beginning, for any situation where we have a keyword in C#, class in this case, that we need to use as if it were a variable or a property, and so we can use that @ in that case. So those are two situations where we use anonymous types within MVC. That said, the other half of the demo I've got here can actually show us a couple of tricks we can do to give us a type for an anonymous class. So if we just go down here to this console demo, what we've got in here is a much more simplified example that shows the exact problem. We've got this getAnonymous that returns an anonymous object with a first name and a last name. The only thing we can really do is return that as an object because we can't name the type. So we put it in there, and here we are doing a write line. And if I run that up, one thing that we'll notice, a nice thing that anonymous types give us, is they do give us a toString. So remember that write line was calling toString, and it's not very clever, but it's enough. It gives us the property name and the value, property name and the value, so we can see Mary Shelley written there. But what we can't do is, I couldn't do anything like anon dot and then specify first name or specify last name. And it's not just one of those situations where we say, well, okay, it's an object, you're going to have to cast it, because that's the fundamental problem. There is no data type that we can cast it to because the type is an anonymous type. One thing we could do, obviously, is we could go for dynamic. So if we go for dynamic, then although we still won't get any IntelliSense support, nothing there, but at least if we know that this has got something called first name, then it will allow us to use that, and we can see it's printed Mary out there. But then, of course, you've got all the problems of dynamic, that any slight typo is going to give you an error. So we can see that it just doesn't know what that is. And also, another problem that you might have here, if you were to try to do something like this, if we were to try and say anon.firstName equals Percy, Looks perfectly reasonable. We check it. We've spelt it right. But when we run that up, we're again getting an exception. And that's because actually of a feature of anonymous types that I hadn't mentioned, they are always immutable. So if in here I was just to say something like that, and then try and say O dot first name. Now in here, of course, we do have the strong type in because we know what the anonymous type is. But if I were to try and put Percy in there, we would get a compile time error telling us that anonymous types only have getters, they don't have setters. So that's why we can't do it if we know the type, and therefore if we do it with a dynamic type, we get a runtime error. So dynamic is a possible solution, but as I say, we know all the problems with dynamic. It's something we want to avoid. Another trick we can go for, and it's quite nice, is we can use a technique called prototyping. And I'll show you how we can do this just in a couple of ways. The first way we can do this is in here, let's write an extension method. I'd normally put it in a separate file, but we might as well just put it straight in here. So we'll have a class called extensions, and I'm going to give that a public static method that's going to return a type T. So you can guess we're going to be using generics here. I'm going to call this from prototype and then declare my generic parameter. And then I'm going to make this an extension method. So I'm going to say this object O, so it's going to extend the object base class. And then I'm going to say T prototype. And then all we do, it's so simple, I'll do it in an inline. We simply take O and we cast it to the data type T. And then the neat thing about that is I can simply do this. I could say var anon equals getAnonymous dot. Well, getAnonymous is returning an object, so I can do the from prototype. And then for my prototype, I can pass in an object of an anonymous type that matches what I want. So here I say new, and then simply first name equals, I don't care what the value is, I just want to set up the prototype, last name equals, so that's enough to make sure it's got those two strings in there. And now if we look there, we've got an anonymous type, string first name, string last name, exactly the same as we've got in there. So it's a bit of effort, but at least it is a way that we can restore the type to it. And so now we can do anon.firstname. And when we run that up, we get Mary. So that's quite a neat trick. Really very little code, but it does mean, of course, we've got to manually get those exactly right. If I made the tiniest mistake in there, then when we try to do the typecast, it will tell us we're trying to typecast from one anonymous type to a different anonymous type, and that's not going to work. The other situation we can use prototyping is actually, what if you would like to have a collection of anonymous type objects, so a list or something like that. Obviously, you could do a list of the object base class, and then whenever you fetch something out of the list, we could use a technique like this one to access it with the appropriate type. But actually, we can, using a similar bit of trickery, declare a list of an anonymous type. So what we do is this. We will say var list equals, and then we start out simply by declaring some kind of collection. And so all I'm going to do here is say new object array of length 0. So we don't need any values in here as yet. We just need something of a collection type. But then comes the neat bit. We say dot, and because this is a collection type, and because we're using system.length there at the top, I can say select, and then O gives, and then I can return an object of an anonymous type. So I'll actually use a prototype. I will lift that bit of code. And so that's what we've got there. And then finally, I'm going to say on that, to list, so we actually get a list from that. So it's a bit odd what's happening here, because we've got 0 objects in the array. Therefore, select will yield an empty collection, but it will have to yield an empty collection of a particular type, and that type is going to be list, because that's what we've declared there, of this anonymous type. So now we can see that we've got a list of T where T is string first name, string last name. And so now what I could do is I could do something like list dot add and then pass in R anon. And then maybe, even though there's only one of them in there, but I could do a for each var O in list, console write O. And so if we run that, we get, after Mary, we get that printed out. So really then, prototyping is the best technique we've got for restoring any kind of structure to these anonymous types. So whenever you've got a situation where you are returning an anonymous type from a function, from a method, or passing it in, whatever, the best we can do is return it as type object. We could treat that as dynamic, but we saw the problems with that. But by restoring it using prototyping, we can give it essentially strong typing once again. That said though, this is what the idea of the tuple, which I'm going to be leading on to, is much, much better at. It gives us the best of both worlds. It gives us the ability to declare types on the fly, but still have names for them so we can pass them around just like anything else. So hope that was helpful as background. Next time we'll be looking at tuples, so do subscribe and make sure you don't miss that.